In this video, I'm going to show you how to make a spreadsheet that will help us calculate an ANOVA table once we put in some data. So our data for ANOVA will always be grouped by rows or columns. So we could either have, in this example that you're looking at now, my data is grouped by small, medium, large, and the data is put into rows. What we're going to use is a feature of many spreadsheet programs called tabs. So if you look down in the lower left, I've added 3 tabs here. The first one I'm calling data, because that's just where I want to dump any data that I copy over from a homework problem, for example. Then I've got a tab called ANOVA, and that's where I want my ANOVA results to be. And then I've got a tab called Data Helper, and that'll do something I'll explain in a minute. So here's my ANOVA tab. On the ANOVA tab, I'm going to have 2 checkboxes. One is going to tell me if the data is in columns or not, and the other one will tell me if the data, if the first row contains headers. In this case, if I say it doesn't, then I lose that header information that you saw I had small, medium, and large. So if I say it has headers, that keeps the group names. This is my summary table. This just helps me calculate these values for my ANOVA table over here. And what the data helper is going to do is it's hard for the ANOVA summary and ANOVA table here to go back and forth between whether my data is in rows or columns. So the data helper is going to be a tab that always puts my data in columns, no matter what my data was that I originally put in. So for example, if I take this data and I change it to being in columns, so here's the same data just in columns. If I look at my data helper, now it's in rows, but I've got to tell my data on the ANOVA table that the data is in columns. So I click that checkbox, and now it leaves it in columns on the data helper. So the data helper will always have our data in columns. Okay, if you want to take on this challenge, let's get started. Start with a blank spreadsheet, and you'll always have a tab down here called Sheet 1. So let me rename this. I just click on that down arrow on the sheet and rename it to data. Hit enter. Now this plus over on the left-hand side says add sheet. I'm going to add one and rename it to ANOVA. And then one more sheet I'm going to have as my data helper. Rename data helper. All right, now the data tab, we don't need to do anything to. We're going to copy and paste data into here from a homework problem. So let's figure out how to handle this data helper. But before we do that, actually, we need those checkboxes so that my data helper knows what to do. So the first thing I'm going to do is give myself some checkboxes. So I'm going to go to Insert, Checkbox. And I'll do another one here. One of these will be to tell whether the data is in columns or not, and the other one will be to tell me whether there's header information. And then give myself a label to know what does that first checkbox stand for. And then the second checkbox, this was to tell me whether the first column contains headers. And if it doesn't, then I'm just going to use generic names for the groups called Group 1, Group 2, and Group 3. Now, if you want to get fancy, you can create a little summary of whether the data is in columns or not using an if function. So if, and I can just click on A1 because the checkbox will be true if it's checked and false if it's not. So if the checkbox is checked, that's what the A1 is, then we say, yes, data is grouped by columns. But if the checkbox is not checked, then we'll say, no, data is grouped by rows. So essentially, this is just answering the question in the cell above, is the data in columns? Right now, no, the data is grouped by rows. If I click this, then yes, the data is grouped by columns. All right, now this checkbox doesn't do anything yet, but we're going to use it to tell our sheets whether the first column contains headers. Okay, let's head over to our data helper tab. And I'm going to put in A1 this formula. So let me explain what this does. This says, so it starts out as an if statement. So I'm going to have if some condition is met, then we're going to do a true. And then if it's not met, then we'll have this false statement. So the first thing I'm looking for is if ANOVA A1 is true. I'll explain the dollar signs in a second. But this means look at the ANOVA tab, then the exclamation, anything after that tells you the cell to look at. So we're going to look at the ANOVA tab and we're going to see, is A1 true? So is it checked? That means we're looking at this checkbox on the ANOVA tab to see if it's checked. And if that's checked, then we're going to perform this statement. What this statement does, the indirect statement, that allows us to reference the information in a cell. And so we're going to reference the cell in the data tab, and then the R tells us that it's the row that we're going to look at, and this row function tells us the row number that we're in right now. So notice I'm in row 1. So the cell that I'm going to reference is data in the row 1. And then the C says look at column, and the column function tells you the column that I'm in now. So notice I'm in column 1. So when I'm in cell A1 on this sheet, this is going to reference cell row 1, column 1 on the data sheet. The false is, we're always going to use that. That just tells us that this is in a particular notation. Okay, if you're curious about the AND statement in these, then what that does is that just puts all these things together. So it's like the glue. So it says look in the data tab, row 1, column 1. All right, so let's look at see what's in data tab, row 1, column 1. Well, nothing yet. So let me copy my data for my homework problem in here. Okay, so now my data is in here. So on data helper, it's going to look for the value that's in row 1, column 1. So this should say small. Now I'm going to get rid of that formatting. This is just a control backslash after I select everything. Gets rid of all the formatting. Okay, so that tells me it's small. Now if I drag this over, so I click on the magic box in the lower right corner there and drag over. Why didn't that work? Well, the reason that didn't work, it actually did. It is looking for, it thinks the data is in rows because on the ANOVA tab, we haven't told it that the data is in columns. So what this is doing is it's saying the ANOVA A1 cell is false, it's not checked, so it's reading the second statement. So notice what we did here is, again, we're referencing a cell, but we're not looking at row 1, column 2, which is where we are. We said the row that we want is actually the column that we're in. So we're in column 2. That means on the data tab, we want row 2. And then the column that we want is the row that we're in. So it's switching this because it thinks the data we want is in rows. But watch what happens if we tell it, no, the data is in columns. So the data on the data tab is in columns. Now it should say medium. All right. So I'm going to drag this over all the way to however many groups you think you'll have. In this class, not too many, but let me go to, let's say, J. That'll give us room for 10 groups in our data. And then maybe down to, let's say, 100. So I'm going to select all the data, all the cells, all the way to J, all the way down to 100. I'm going to hit Control D or Command D on a Mac, and that just makes sure that however much data I put in, as long as it's not 10 rows worth, 10 groups worth, and the data in each group is not down to 100, past 100, then we should have plenty of room. And you can always adjust that if you happen to have a problem with more data. Okay, so what I want to do is check to make sure that this is working. I want the data helper to always be in columns. So what happens if I change this to be data that I copied in rows? So now my data is grouped in rows. If I tell that to the ANOVA sheet, then my data helper is still in columns. And that's what I want. I only want to deal with my data in columns. So even if I copy and paste data in rows, it's going to calculate based on the data in columns. Okay, the rest of our work can be done on the ANOVA tab. So the first thing I'll do is write out some labels for all my tables that I'm going to create here. First, I'm going to have a summary table. And in that summary table, I want to know what are the groups, how many things are in each group, so I'm going to call that the count. Now this is going to be useful for one of the formulas we need to calculate the ANOVA results, the inverse count. That's just 1 over the count. I need the sum of each group. I need the sum of the squares of each group, so I'll just call that sum squares. I need the mean. I need the standard deviation of each group and the variance. And really you only need one of those, but I'm going to calculate them both just for fun. And then I'm going to create a separator here. So I like to highlight the entire column and color it some sort of gray. Use whatever you want. Just separate the two tables from each other. So now I need a place to input my significance level. And then I'll start my ANOVA results. So in this table, this first column will be my source of variation, and it'll be either between groups as my first row and within groups for my second row. And then I'll calculate the total. Then a few columns here. I need to calculate the SS between groups and within groups. I need the degrees of freedom between groups and within groups. I need the mean, the MS, the F test statistic, and then I'll have my table calculate the p-value and the critical value. So whatever the question is asking us to calculate, p-value or critical value, we'll have them both. All right, now just a useful distinction between your labels and your data. I'm going to bold these, so I select them and hit Control B, or come up here and hit the B button. That just makes your labels look a little nicer. So how about let's get all these, make them bold, use some color if you want. All right, and then you might like to, because it's usually these ANOVA tables are usually presented with different cells that are distinct, we can hit some, throw some borders in here. All right. Now, let's start out getting the values for our groups. And what I want is to be able to drag this down and have my formula calculate the group names for each one, each group. But notice this is in row 7, and I want it to start out getting the group for the first group in the A column. So here's what I do. I'll use this formula, again, get rid of my formatting. So again, I'm going to use an if, and I'm going to say if the count of, and I'm referencing the data helper, so using the indirect function, the data helper in column, and whatever the row minus 6 is, equals 0. So row minus 6 says that, okay, I'm in row 7 right now, so minus 6, that will tell me, all right, if there's no data in the column 1 on the data helper, then I'm going to do nothing. So notice I have a comma, comma. So if the count is 0, there's no data in that first column, do nothing. But if there is data then, so then I'm going to use another if function. And here's where I want to say, if there's already a label, then use that label. But if there's not, then I'm going to call it a group 1. So I say if A3, meaning if that A3 box is checked, then reference that first cell, row 1 on the data helper tab, column, and then row minus 6. So whatever row I'm in, 7 in this case, minus 6. So for this one, it will be row 1, column 1. But then on the next row where I'm in row 8, it would be row 1, column 2. I'd get that label, etc. But remember, we're in an if statement. So if the A3 box is not checked, then we're going to use this formula where I take the word group and then I combine it, that's what the and is for, with the number that is row minus 6, the row function. So in this case, it would be group 1. So because A3 is not checked, row minus 6, I'll be using this group in row minus 6, so it should tell me group 1. And then if I click this box to tell me there are headers, now it's going to use the header from this first one. And so what should happen when I drag down is it will go all the way, it will get all those labels. So drag this down, and 17, because remember, I only gave myself to column J, so I should only have 10 at the most, 10 groups. And it is possible to have more groups, not likely in this class, but it could happen, and so you might need to adjust these a bit. Now let me explain what the dollar sign is in these formulas. Normally, when you drag down, like we have been, the cell that's being referenced will also drag down. So in other words, if I drag this down, as I did, where I was referencing A3 in the first row, the next row would then reference A4. But I don't want that because I want to always look at this checkbox to see if it's checked. So the dollar signs hold that steady. So they say, even if I'm dragging down, freeze this reference to A3. So in each of these functions, it stays referencing A3. So it's always looking for A3 to see if that's checked. And if it's not checked, we're going to use generic group names. Otherwise, use the names provided. Okay, now let's look at the count function. The count function is a little more straightforward, but still using our formulas that we've encountered in this one, like indirect and count. So again, we're checking to see if the data, if there's no data in that column, do nothing. So we're looking at the data helper column 1, that's the row -6. We're going to reference that cell data, and then we're going to, or that the entire column, and then we're going to count how much data is in there. And if there's 0, we don't want to do anything with that column. But if there is data in there, we want to know how much. So we're actually going to count how much data is in that column. All right, and there were 7, I'm looking at the data helper tab, there were 7 numbers in here. So the count function gave me that. And I'll drag this down again. Now this function, inverse count, this is just a simple one. I want the inverse that is 1 over the count. But the problem is, if I just do 1 over the count, 1 over 7, because I could have done this in whatever formula I needed it. But as soon as I get down here, where there's nothing, it says division by 0 and gives me an error because it's trying to do 1 over nothing. So instead, what I'll do is I'll throw this in an if statement. So we're going to say, if that count is blank, so I'm going to use the is blank formula and reference, in this case, B7, then do nothing. But otherwise, do that division. So now, anytime it sees the column to the left being blank, it's just going to do nothing instead of try to divide by 0. And that gets rid of the error. Now to calculate the sum of each column in my data helper sheet, I'm going to use, you'll get familiar with this formula, this part of the formula, if count indirect data helper column row -6. And again, that's just checking to see if there's 0 data in that column, then do nothing. But otherwise, I'm going to use the sum function to calculate the column data helper column, and in this case, column 1. And let's copy that down. And then I'm going to copy this formula over again because most of it's going to be the same. But in this case, I want to use a slightly different formula than sum. I want to use the sum SQ, which will give me the sum of squares. And then let's copy that one down. Oh, a little too quick there. Sum squares. Enter. Now it's suggesting that I fill, but I want to fill more than just those two, so let's fill all the way down. And the reason we want to fill all the way down is, again, just in case we come up with a question that's asking us for, we're going to put more data in here, more groups. All right, then I can come over here and copy and paste the same formula, but change the sum of squares to average, because I want the mean. All right, and copy that down. All right, we're rolling now. We're almost done. Let's do the same thing. Copy, paste. And instead of average, I want the std, ev, and just to be sure, call it the sample because this is a sample standard deviation, stdev.s. Copy it down. And then in this function, we could either square the data in the standard deviation column, or just to be sure, we can use the var.s for sample. Calculates the variance of a sample. And you can double check that these are just the squared values of the numbers to the left. Okay, to calculate this first cell in our ANOVA results table, what we're going to do is we're going to take the square of each of these values in the sum column, so the sum of each group, we're going to square them, then we're going to divide by the count, and then add those all up, and then finally, the next thing you do is subtract off the sum of all these sums together, so we're going to add all those together, square it, and divide by the total number of data points. And that's just adding up all these counts. So here's where we had to get a little tricky. In our formula, instead of just taking the square of the sum and dividing by the count, because that starts complaining once we get anywhere where there's no data, this is where we're just going to multiply the squared version of 39 times the 1 over count. All right, so let's do that. The formula we're going to use looks like this. So we're using this sum product, which means first we've got two columns. That was the sum column and the count column. We're going to look at these pairwise, multiply them together pairwise. So that means multiply each value in each row pairwise and then add them all together. But notice I've got this caret 2, which tells me first square the values in the D column and then multiply them times the values in the C column and then add all those up. All right, and then let me point out the rest of this, minus, here we're using the sum formula to add everything in the D column. That was our sum, so we're adding these numbers up first, then squaring it, and then dividing by, add up everything in the count column, B column. All right, that gets us our first value in the ANOVA results table. Okay, then I'm going to move down, and we have a couple options here. We could either calculate this cell within groups under the SS column, the sum squares column, and then add these together and get total, or the way I'm going to do it is actually calculate the total, because we have a formula, nice easy formula for that, and then subtract from the total this between groups, and that will be my within groups. So let me show you what the formula here looks like. Just using the sum formula a few times, but I'll explain. What we're doing is we're adding everything in the E column, which is our sum of squares. So we've already, for each group, squared each data value and added it together, and now we're adding all of it together. So that's the sum of the E column. And notice, to get the whole column, I should have pointed this out, we just type in E colon E, and that tells the spreadsheet to calculate the sum of the entire E column. So as long as we don't have any data above some squares that we don't want included in that sum, we should be okay. Then we subtract off the addition of all the data added together and then squared, and then finally divided by the number of data that we have, which is the sum of this B column. All right, so here for the within groups, I can just say equals the total minus the between. To calculate degrees of freedom between groups, I just have to count the number of groups. So I can say equals count and come over to my number of groups. Let's go in the count column all the way down to 17, and it should count only 3 in there. But if I had more groups, then it'll count more. But the degrees of freedom between, or for the numerator, is always -1. So I have 3 groups, but -1 gives me 2. Now, for the degrees of freedom within, I'm going to find out how much data I had in total, and then subtract off the number of groups that I have. That's the degrees of freedom for the denominator. So the way to figure out total amount of data is just count, sum of all this data in the count column. And then minus, and let's count the number of data that are in this count column. So the sum is going to add those counts for each group to give me 25, and then minus the 3 groups, which is what I get from the count function. And then we can just add these 2 together to get the total degrees of freedom using the sum function, or you can say first cell plus second cell. Okay, you're almost done. The rest of this is pretty straightforward. Let me just point out that on the bottom row of this ANOVA table, we can black that out because there are no values that are put in there. And then to the right of the MS column on the second row there, we can black that out too. We're not expecting any values to go in there. So to calculate the values in the MS column, it's simply the value in the SS column divided by the degrees of freedom. And you can drag that down. And then to get the value of your F test statistic, it is simply the MS between groups divided by the MS within groups. And now you have your F test statistic. Now to calculate the p-value of this, I'm going to use the f.dist.rt for right. That's the F distribution for right tail. These will always be right tail for us, and all I have to do is input my F test statistic, but then it also needs your degrees of freedom in the numerator and your degrees of freedom for the denominator. And you've got your p-value for this test statistic. And for the critical value, similar idea, it's just we're going to have to use the f.inv and then rt for the right tail. And now I want to put in my significance level. Notice I haven't put a significance level in here, so I'll come back and fill that in a second. But let's click where, looks like I'll have this in K3. We'll put in probably a 0.05 if it's not otherwise stated. But this one also needs a comma, degrees of freedom numerator, degrees of freedom denominator. So it gives me an error right now because it doesn't see a significance level, but let's put one in here. And now it tells me my critical value. So in this particular example, my p-value is bigger than the significance level, so I would fail to reject the null hypothesis. Or if it's a critical value, just notice that the test statistic is not further to the right than the critical value, so you fail to reject the null hypothesis. And that's it. Now you can copy any data you want from a homework problem onto this data tab. Make sure you delete the data that's in there already. So I can just select everything by clicking this box in the upper left corner, hit the delete button, it goes away, copy in new data from a new homework problem, tell the ANOVA tab whether the data is in columns or not and whether there's headers or not, change your significance level, and then everything will be calculated for you. All right, good luck on these ANOVA problems.